Hey guys, welcome to Brillianaire, a 501c3 nonprofit dedicated to providing students in underprivileged communities with free educational opportunity. Today we're going to be looking at a very famous Leetcode problem called Twosum. We're going to be discovering the 3 different solutions and we're going to be coding the most efficient one and running it in the problem on Leetcode. So without further ado, let's get started. Okay, so here on my screen I have pulled up a whiteboard, and on the left you can see a little snippet of the problem. And on the right, I've just written down the array given in example 1, and I've written down the target sum, which is t in this case. So let's look at the problem really quick. Given an array of integers nums and an integer target, return indices of the 2 numbers such that they add up to the target. And you may assume that each input has exactly one solution and you can't use the same element twice. So this gives us 2 things. One, we know that there is a solution for every single input and there's only one of those. Right? So we don't have to worry about any null solutions and we don't have to worry about multiple solutions. So we can just proceed along with this code. So let's talk about the logic first. When looking at this problem, the first thing that comes to most people's minds is the brute force solution. And that is going through each element of the array and figuring out all the possible sums that you could get and seeing if one of those sums matches the target. And if so, then we just return the indices of the 2 numbers that add up to that sum. So the way this brute force solution works is that you have 2 pointers. So you've got one at the 0th index and one at the 1st index. And all you're going to do is add these 2 numbers together, calculate the sum. If it equals the target, then you output the 2 indices. If not, you increase this pointer by 1 and you go through all the numbers. And once you get to the end, you increase your first pointer by 1 and you start again over here with this pointer. Now, the reason you don't start at the beginning with the second pointer after one full loop is because you don't want to add the same numbers twice. Because if we started the second pointer at the 0th index after this first loop has been done, then we would be adding 2 and 7 twice, since we already did that on the first step of our program. So to avoid those duplicate sums and additions, we just start the second pointer at an index above where the first pointer starts. So if my first pointer starts at 7, then we start our second pointer at the index right above that. So we start it at this index right over here, which is corresponding to the number 11. And so, yeah, basically you just go through, you have 2 pointers, you go through the whole array, you check all the sums, and eventually you'll find your target sum, and you just return the indices of the 2 numbers that add up to your target over here. So now this brute force solution, while it may sound simple, it's very inefficient, because if we look at the time complexity of this, we're going to be going through the loop n squared amount of times. And so at worst, we are going to have a time complexity of O of n squared. And the reason for that is because we go through the whole loop, right? So we do n number of processes, and we do it for each element in the loop. So we do n number of processes for each n number of elements, which gives us n times n. Now we're doing n times n processes, which gives us O of n squared as the worst case scenario for this brute force solution. And obviously this solution is very inefficient, so let's see if we can figure out a better way to solve this problem. Okay, so the second solution that comes up, which is a little bit better than the brute force solution, is a sorting method. And what you're going to do is you're going to be able to sort this array first. So let's say we use something like merge sort. That's going to take O of n log n time just to sort this array. And so now let's say you have a sorted array. Please excuse my bad handwriting, but let's say you have a sorted array here, right? Which is exactly the same as this first array. But let's say that this first array was not sorted or something like that. Then we would have a sorted array down here. And what we would do from there is we would have a pointer that starts at the 0th index, and we look to see what number is at the 0th index. And we see that this number is a 2 in this example. So we know that our target sum is 9, right? So all we have to do is find a 7, because 7 plus 2 is 9. So with that information, we can find the complement of 2, which is just the target minus the number, and that's 7. So all we have to do is search the array for a 7, and if we find a 7, then we can just return the indices of the 2 and the 7. If not, we can increase the pointer to the next number. And so the way we try and search for a 7 is using binary search. So since we sorted the array with merge sort or some other algorithm, it's giving us O of n log n time. Then we just use binary search to search for the complement of each number, and that's also going to take O of n log n time. And so once we do that, we will eventually get a match, right? And once we get a match, we can just output the two indices of the numbers that add up to our target sum. So this solution, using sorting and binary search, is going to take, again, it's going to take O of n log n time at worst. And so, okay, this is a bit better than our brute force solution, which took O of n squared time, but it's still not super efficient because it takes O of n log n time, and there's a solution that does a lot better. So the next solution we're going to be talking about consists of a hash map, and this one can be done in O of n time, so linear time. And let's go right into that, starting now. Okay, so now that we discussed two solutions that are sort of inefficient, let's talk about the most efficient solution to this problem, which uses a hash map. So a hash map is basically just a dictionary. It's got a key and a value, and all we're going to do is this process. So we have a pointer, and we started at the 0th index, and we also have a hash map. I'm going to call it HM, and we are going to keep it empty for now. So our hash map is empty initially, and all we're going to do is start a pointer at the 0th index. Now we see that the pointer points to a 2 in this case, right? So we know that all we have to do is find a 7. And if there's a 7 in the array, that means that those two numbers will add up to our target sum, which is 9. And we can just output the indices of those two numbers. So let's store that somewhere. So let's say that the complement, I'm just going to say C, the complement is equal to the target minus the number that we are looking at right now, which is 7 in this case. So we know that the complement of 2 is 7 for this problem, and so all we have to do is find a 7. So now comes our hash map. So right now our hash map is empty. So the way this problem works is you look at a number, and you check to see if the complement of that number is located in your hash map. And if it's not, then you just add the number that you're looking at currently to the hash map. And if by chance the complement is located in the hash map, then your job is done. You can just output the indices of the number in your hash map as well as the number your pointer is looking at currently. So to break that down a little bit, let's go through this problem step by step. So we know that we're looking at a 2 right now. The pointer is at the 0th index. And the complement of that is a 7. So we look at our hash map to see if there's a 7 in that hash map right now. And so right now it's empty. So obviously we don't find a 7. So all we're going to do is add this 2 that we're looking at right now to our hash map. So I'm going to say 2 colon 0, where the 2 represents the number and 0 represents the index. Okay, so I'm going to call this n and index. So n represents our number or our value, and 0 represents the index of where that value is found in the array. So now that we have this hash map, we increment our pointer by 1. Now we're looking at a 7, right? So we find the complement of 7, which is 9 minus 7, which equals 2, right? So now our complement of the number we're looking at right now is 2. So all we do is check our hash map to see if a 2 exists in it. And yes, a 2 does exist in our hash map. So now we know that we have all we need to solve the problem. All we have to do is just output the index of the value in our hash map, and we have to output the index of the value that our pointer is looking at right now, which is 1. And as you can see, that is the solution to the first problem, or first example right here. And yeah, that's basically the whole solution. So this requires a hash map, which means we sacrifice a little bit of memory, but we minimize the time to linear time. So instead of having O of n squared or O of n log n, we now have a time of O of n, which is very efficient. We have linear time. The only problem is we have a memory complexity of O of n as well, because at worst, we can store every single element in the array in our hash map. So it does consume a little bit more memory, but I'd say the trade-off is much better because we reduce the time to linear time. So this, in my opinion, is the most efficient solution. So let's go ahead and code it up and submit it to Leetcode. Okay, so now we're on VS Code, and as you can see, I've defined a function here. I have nothing in it yet because we're going to be writing this part. And I've also written down the main command, and as you can see, we have defined nums and target, which is our input. And we're just going to be printing our output of our function. So let's go ahead and write this function. So first things first, we're going to be wanting our hash map, right? So let's call this Hashmap, and let's have a comment that says val : index. So we know that the key for this hash map is val followed by the index. So the value followed by the index. Okay, so now that we have that, all we're going to do is go through the input array. So for I, n in enumerate, there we go, nums. So what this is going to do is it's going to go through the input array, and it's going to take in the index as I and the value as n. So now that we have those things, we can carry out our problem. So now let's say that the complement is going to be our target minus the nums of I. Or sorry, we can say n, my bad. Okay, so our complement is just target minus the number we're looking at currently. So now that we have our complement, we can use this to carry out our solution. So if complement in the hash map, then all we have to do is return, and let's put this in an array. So we just need to return hash map of the complement and followed by I, which is the index of the value that our pointer currently looks at. So if our complement is located in the hash map, we just have to return the index of the complement value along with the index of the current value we're looking at in the array. And else, let's say we don't find it, all you have to do is add it to our hash map. So hash map of n equals I. Okay, so let's go ahead and get rid of this. So now that our function is basically written, let's go through it one time before running it. So we initialize a hash map that's empty. We go through the nums array. We find the complement for each number. And then if that complement is in the hash map, then we return our indices. And if not, we add the value we're currently looking at to the hash map. And so if we run this with our input array being 2, 7, 11, 15, and our target sum being 9, we should get an output of 0, 1. And bingo, there it is. So yeah, that was basically our O of n solution. Now let's go ahead to Leetcode and submit this problem. Okay, so here I am on Leetcode. I've just copy and pasted the code from our terminal. And all we're gonna do is hit run first just to see that it works. And cool, it works out. And so let's give it a submit and let's see what happens. And as you can see, there we go. Accepted. We have a runtime of 91 milliseconds, which is much better than this time over here, which is the root force solution. So as you can see, we save a lot of time, and given a very big input array of size n, we can save much more time when using the O of n solution as compared to either the O of n squared solution or the O of n log n solution. So although we do sacrifice a little bit of memory, I think it's much better to have a linear running time than a quadratic or n log n running time. So yeah, thank you all for watching. This was a Leetcode problem twosum. We discovered 3 different solutions and we coded up the most efficient one and submitted it to the website. So yeah, thank you all for watching and stay tuned for the next episode. See you next time, Brillianaires.